All right, this is a complex circuit, and if you can tell by looking at it, there's going to be some issues with it. Specifically, number 1, 3, 8, and 5 are going to cause you some problems here. So let's go ahead and get started on this. One thing about 5, 6, and 7, we've got all of them in a series, and there's nothing keeping you from combining those three. And with the circuits that we've had so far, I haven't given you a situation like that. So you're going to be able to simplify this relatively quickly once you get this moving. So let's go ahead and do that. So I'm going to combine those three, 5, 6, and 7, in a series combination for total resistance on that. So let's draw this thing out. So we've got 1, we've got 3, and then way out here, we're going to have 5 through 7, okay? And then we go back and we find 8, and we go over here and we find 9, and we have 2, and we have 4.
Would you then combine 3, 4, and 8 because they're all in series?
All right. So what we've got right now is after I copy these things down, so 5 plus 6 gives me 11, and then we get 18 right here. You combine all three. Okay. 4 is still 4. This is still 8 right here. This is still 3 right here. 2 is still 2. 1 is still 1. And 9, for some reason, is 11. All right. So now when I look at this, I'm going to be combining these right here in parallel. So I do 1 divided by parentheses 1 over 4 plus 1 over 18. And you get 3.27 rounded. Okay? All right. So I move on to my next diagram, combining 4 through 7. All right. Now I look at what I have, and on this particular circuit, I've got these right here in a series. Okay, this one, and this one are in a series. All right, and so I'm just going to add those together. So that's going to be 11 plus 3.27. So it's going to be 14.27 on our new diagram. That's going to go right over here. So 14. This is going to be 3 through 8, and that was 14.27.
Okay.
This is 9. It's going to be 11 ohms. I've got this. That's number 2. It's 2 ohms. And I've got 1. It's 1 ohm. Okay. So when we get here, we see that we are going to combine this section right here in parallel. And so I go 1 divided by 1 over 2 and 1 over 14.27.
1.75.
That's right. I can't see the diagram. That one's bigger.
And we get 1.75. And that's going to be my ohms for that section. As I move up to this diagram, which will have 14 volts.
That is the.
I'm not there yet.
Yeah. Wait, I didn't see that.
Oh, I saw it.
1,
No, I did. That's glitch,
2 through 8,
bro.
and 9. This was 11 ohms.
And you combine all.
This is 1.75. And this is 1.
13.75.
And so my total resistance is 13.75 ohms. My voltage has been 14 through all the diagrams, so that's my total. And so I need to calculate my total current. And my total current will be 14 divided by 13.75. So it's going to be really close to 1. Okay. And so 1.02 is my total current. Okay. And so I'm going to shuffle that over just a bit so I've got room to show all the work on the way back through. And all of that work will be done in...
Wait, so how do you get 13.75?
You combine all the.
this color. All right.
All those.
All right. So as I go back through, this was a series circuit that I did in red. And so since I've got my resistance, that's going to give me my current. So my current for all of these is going to be 1.02. So this is my resistance here. The current is going to be 1.02. And this is my resistance here. The current is going to be 1.02.
So, Coach, for number 1 and number 9, you could go ahead and just fill in the current.
You can. All right. And so we are going to calculate our voltages here. And 1 and 9 are going to go directly into the table. And so 1 times 1.02, that's going to be easy. So this is 1.02 amps. And it's consequently going to be 1.02 volts. Okay? And so on 9, I'll go ahead and do 11 times 1.02. And that gives me, that's on 2. Whoops. So on 9, so 1.02 amps and 11.22 on volts. Okay, now I still need to calculate the voltage for 2 through 8. This is going to be useful to us here in just a second. So I go 1.02 times 1.75, and I get 1.785. All right, now that voltage is going to apply to this parallel section right here because voltage is constant in a parallel circuit, and that section that we got 2 through 8 from is parallel. So I'm going to have my resistances here already. And so I am carrying the voltage down that we just calculated, 1.785 volts, 1.785 0.85 volts. And I'm going to need to calculate the current for both of these. Okay? And so voltage is always on top. So on 3 through 8, I do 1.785 divided by 14.27, and I get 0.13 rounded. And I do 1.785 divided by 2, and I get 0. We'll round this 89. All right. Luckily, 2 gets solved right here. So 1.785 volts on that, and we had 0.89 amps. All right. Now I need to figure out how I got this number right here, the 14.27. And I got that on the previous diagram by adding those numbers together. That means it was a series circuit. So in that series circuit, current is constant. So the 0.13 amps is going to be applied to all three of these things. We've got our resistances here, here, and here. And so we're going to get the current, and that was 0.13 amps. Current here is 0.13 amps, and the current here is 0.13 amps. We got to figure out that voltage for each of these. We do that by simple multiplication. I'm going to start with number 3. This is going to go directly in the table after we do this. So 3 times 0.13 is 0.39. Okay. And so I'm going to go over here to the table, and 0.13 amps and 0.39 volts. Okay. I'm going to go ahead and do 8 next. So 8 times 0.13 is going to give me 1.04 volts. So I put that in my table, 0.13 amps and 1.04 volts. And now I do 4 through 7. I'm going to need this number. So I do 0.13 times 3.27. And it gives me 0.43 rounded. All right. Now, on the previous diagram, I got the 3.27 resistance by using a parallel circuit resistance right here. And so that voltage is going to come up, and it's going to apply to 4 and 5 through 7. So if my resistance is here, I'm going to bring my voltage up. 0.43 and 0.43. And I need to get my current for both of those. And so I do 0.43 divided by 18, and I get 0.02 amps. And I do 0.43 divided by 4, and I get 0.11. Okay? And so I can put 4 directly in the table. 0.11 amps. And voltage is 0.43 volts. And then the last part that I've got, I'm going to carry this current up to 5, 6, and 7. So 0.02, 0.02, 0.02, and I multiply that by 5, that gives me 0.1. I multiply this by 6, it gives me 0.12, and then this is 0.14, and we are done.